All right, let's take a look at the homework for lesson 6.4. It says write the equivalent fraction. You're changing a mixed number, 6 and 2/5, into a fraction. So you could either decompose it or you could multiply the denominator by the whole number and add the numerator. So you've got a situation where you've been divided into fifths. There's 6 wholes, so 5 times 6 is 30, plus 2/5 is 32/5. 5 times 6 plus 2 is 32/5. Okay, multiply the denominator times a whole number and add the numerator. You could do that over here. 8 times 2 is 16, 17, 18, 19 eighths. I've just changed the mixed number into a fraction. And then down below, it says write the equivalent mixed number. So here's a fraction, 50/7. You divide the numerator, 50, by the denominator, 7. 7 will go into 50 7 times. 7 times 7 is 49. Subtract. Remember, you take the divisor and write it underneath. That's the denominator. The final answer is 7 1/7. 7 wholes and 1/7 of another one. All right, so let's look at the word problems. Castor brought 6 3/4 small carrot cakes to share with 26 students in his class. Did Castor bring enough for each student to have, and this is important, 1/4 of a cake? Explain your thinking. So show your work over here. There's 6 3/4 small carrot cakes. Change that into a fraction, like you did up above, and that should come up with, the numerator will tell you if you have enough or not. All right? Remember, there's 26 students in the class. The numerator will give you a clue as to whether or not there's enough for everybody. All right, so try that and see how you do. Now, Claire cut some apples into eighths. That's important, and I've drawn that out over here, eighths. She and her friends ate all but 17 pieces. How many whole apples and parts did she have left over? Okay, so if there were 17 eighths left over, right? 17 eighths. Color these in until you've colored in 17 of them and see if you can change that into a mixed number. Okay, how many whole apples and parts? So change this into a mixed number. Now let's look at remembering real quick. It says write and solve an equation to solve each problem. Draw comparison bars. So Bridget fostered 14 dogs this year, which is 5 less than last year. How many dogs did Bridget foster last year? So that's the question. That's what we're solving for. So let me read this again. Bridget fostered 14 dogs this year, okay, which is 5 less than last year. So that tells me that last year was a bigger number. How many dogs did she foster last year? So if I take last year's number, right, it's 14 plus 5. Okay, using inverse operation. Or you could say last year, whatever they had last year, if you take 5 away from it, you'll get this year's, which was 14. Either one of those equations would work. All right. So see if you can figure out how many they solved last year. Now, Rima has 2 jobs. In 1 year, she worked 276 hours at her first job. In the same year, she worked 3 times the number of hours at her second job. How many hours did she work at her second job? So let's read this again. Rima has 2 jobs, got it. In 1 year, she worked 276 hours at her first job. And in the same year, she worked 3 times the number of hours at her second job. Tells me her second job is going to be a larger number. So I like to use the lesser quantity, greater quantity table to help me figure these out. I know her first job was 276 hours. She worked 3 times the number of hours at her second job, so I'm going to multiply that by 3. That should give me the number of hours that she worked at her second job. So do those 2 problems and then be careful. I want you to do 6, 7, and 8. Remember, the denominator stays the same. And this will be bonus. Number 9 is bonus.